for current, for AC current, its graph is a sine wave, sine graph, okay? So actually, if I want to get the average current, because usually for DC circuits, if it's DC, the current will be constant. So it's easier to do calculations with it. But AC, you see that current will have its peak current. You also have zero current, right? And you also have in between, right? And also because the above and below are all the same, if you want to measure the current average, you'll be zero because the above and below cancels out. But it's not zero, right? It's not true. So how will we do this? Okay. So first of all, we need to tackle the negative current. Okay, how do we do that? We square it. Okay, squaring it means negative, square means positive. Okay, so we'll get something like this. It'll be a higher sine graph. Okay, so originally for this, its equation of current is I equals to IO sine omega t. Okay, basically IO is peak current. Okay, and then it's a sine function, it's a sine graph. Okay, omega is its angular speed. Okay, I equals to IO sine delta t. If I square the whole equation, I'll get I square equals to IO square sine square omega t. Okay, now recall trigo functions. We know that cos 2 theta equals to 1 minus 2 sine square theta. I let theta equals to omega t, so cos 2 omega t equals to 1 minus 2 sine square omega t. And so rearranging, I get sine square omega t equals to 1 over 2 minus 1 over 2 cos 2 omega t. Okay, substituting this to this, we'll get I2 equals to I naught square 1 over 2 minus 1 over 2 cos 2 omega t. Okay. Okay, so this is another way of explaining the graph. Okay, so look at this. This graph is same as this, exactly the same as this. If I want to get the average, right, I need to look at this equation. Okay, specifically look at this. Cos 2 omega t. If I draw it out, the function will just be like something like this. Okay, and because the positive and negative side are equal, when I get the average, this is actually equal to 0, right? Because the positive and negative side are 0, so they cancel out and then you get 0. So actually the average I is actually equals to I naught square 1 over 2 minus 0. So average current is actually equals to 1 over 2 over 2 1 over 2 million. So and then the root mean square of our current, okay, root mean square is actually equals to I naught over sub 2. So for this whole thing, we call it current root mean square. Okay, basically it means the root of the average current square. Okay, the root of the average current square. This is the formula. Okay, so you can see that the root mean square current of the AC current is actually 0.71% of the peak. Okay, so actually, let's say this is my peak. I naught is the value. Let's say this is 1. My average current would be somewhere around here. Maybe a straight line here, and it's like about 0.71.